Okay, hello students. Once again, you're welcome to Waidsum University. Please, we indulge you to subscribe to our university YouTube page. Okay, so today we're in chapter 6 of networking essential management, or simply called networking essentials. So we're in chapter 6 part 1, chapter 6 part 1, called the TCP IP. Okay, so before we begin, we will look through the objectives, today's objective. Okay, so without much ado, let's begin. Now today the first part is the introductory part. We're going to introduce, which is 6.1. so you remember, for this course we always divided it to different sections. Section is its own PowerPoint. 6.1 is its own class. 6.2 is a different class. 6.3 is a different class. 6.4 is a different class, like that up to 6.7. So we have them, like each one has its own unique classes. This is how we spread it out, because if we put everything in one course, it will be so overwhelming. Is that okay? So today's course, the first one is the introductory part, which we're going to look at for today. But subsequently we look at the second part, which is chapter 6 part 2, which is the TCP IP layers. Okay, because it has its own layers, like the way we have the OSI model, we also have the TCP IP model. Okay, then number 3 is the number conversion, how we convert numbers, binary number and digital decimal numbers to binary, hexadecimal, so on and so forth. And then the fourth part is the IP address version 4. The IP version 4 addressing, we will look at it, the previous one. Then we look at the 6.5, the subnet mask. We look at the subnet mask, and then after that, chapter 6 part 6, we look at the CIDRO blocks. After that, we look at the IP version 6 addressing. So this course is in several segments. So the first one is to look at the objective of the entire chapter. First, we're going to define how a TCP connection is established in a system, in a network. And then we investigate the properties of the UDP connectionless protocol. We look at the properties. Let's take our highlighter, our usual highlighter. Okay, we look at, first of all, we look at the TCP connection, how it's been established, and the second of it all, we look at, we investigate the properties of the UDP connectionless protocol. We look at that, and then the third one is to look at the 5 classes of IP addresses, and then the next objective is to look at or investigate the properties of basic number conversion system and number system, and then we look at the purpose of subnet masking, and then after that we look at we investigate the implementation of CIDRO blocks and the SuperNetty. And then after that we look at how to apply the subnet masking concept to allocate space for hosts in the subnet. Okay, and then after that we look at the protocols, the protocol analyzers. Okay, we look at the protocol analyzers, and we can use it to analyze the TCP data packets. Okay, so we look at the protocol analyzer and how we can use it to analyze our TCP data packet, any data that is be transmitted on this protocol, using this protocol, TCP IP system. Okay, then we will look at the address structure of the IP version 6. The IP version 6, we look at the address system or address structure. Then we will analyze the TCP data packet as well. We think we've kind of said that. So these are the objectives for today. Now let's take a look at the first part, which is this first part, introductory part, which is the 6.1. Okay. First of all, what is a TCP? That's the first thing. What is a TCP? Okay, what is TCP? What does it stand for? What does it mean? Okay, we say is that a TCP is a suite. First of all, a TCP really stands for transmission control protocols. It stands for transmission control protocols. Is that okay? So we say this transmission control protocol, that's TCP. Then the IP is Ethernet protocol. So we say TCP/IP, Ethernet protocol, right? We say it's a suite. The TCP/IP is a suite, okay, of a framework for organizing sets of communication protocols that are used on the internet. So it's a suite of frameworks for organizing sets of communication protocol that are usually used on the internet, okay, or any other computer network. or any other computer network to communicate or to help to transfer data from one point to another. That's the communication protocol that data's use or follow in computer system. Okay, so in other words, we can also say it in this manner, that TCP IP is the protocol suite for communication. Is the protocol suite for communication. Okay, it's a framework of protocol suite that is used for communication between what? Between the host in most local networks and on the internet. The host of computer in local area networks, and all the networks on the internet, which includes the wide area networks. Okay, TCP/IP stands, like we said before, it means transmission control protocol. It means transmission control protocol. The IP is Internet protocol, so we can simply call it the IP, or you call it the TCP. It's the protocol upon which data can be transmitted. Okay, every data has the protocol upon that it's adhered to for transmission. This protocol upon which data can be transmitted, or in a network, or in a host in a network, or on the internet, is called the TCP/IP. Now, this TCP/IP is used for enabling network communication in LAN. So for enabling network communication in local area network, for enabling network communication in campus network, in enterprise network, and also even including the wide area networks. Okay, enabling network communication even in wide area network, because it's an internet protocol. Okay, as long as the host support the TCP control protocol, as long as the host computer support the host computer support the internet protocol itself. Now, TCP/IP is widely supported, and it's included in the operating system. Okay, the Microsoft operating system that you're using support the TCP/IP protocol. Is that okay? In Windows 9X, NT, ME, 2K, XP, Unix, okay, Linux. So all of these support the TCP/IP protocols. All of these operating systems support the TCP/IP protocol, because it's an internet protocol that enables data to be transmitted on a network or on the internet. Is that okay? Okay. Now let's take a look at a bit background of this TCP/IP, how it came into being. Okay, this was, first of all, the TCP/IP was developed in 1978, so to say. Okay, first of all, TCP/IP was developed by who? By the Defense Advanced Research Project Agency in the United States. The Defense Advanced Research Agency Project Agency, called the DARPA, to provide a way to network the computers of government researchers together. So they wanted to network the computers of all government researchers, because we have government researchers in different fields, in maybe in engineering, in science, in management, in sociology, in military, in defense. So this agency was developed to bring together, to link together all the researchers of government agencies, okay, be it from any field. Okay, now this DARPA, this Defense Advanced Research Project Agency, which is called the DARPA, this DARPA was a funded initiative by the federal government of the United States. Okay, was a funded initiative, and it forced the use of a standard networking protocol. Because it was a funded initiative by the government, this was forced to coerce all the networking protocols to be one, to use one standard by all the defense contractors in the United States. Okay. So in 1978, the suite of protocols called the TCP/IP was given birth to. This protocol was given birth to in 1978, okay, by this DARPA. Okay, they came up with a standardized networking protocol called the TCP/IP, Transmission Control Protocol / Internet Protocol. Is that okay? So in 1970, they came up with this, and this one was now widely accepted. In 1983, the TCP/IP replaced the previous protocol, replaced the network control protocol, the one we had before it. The network control protocol was replaced by the TCP/IP as the standard networking protocol used by the Advanced Research Project Agency network, which is called the ARPANET. the ARPANET, Advanced Research Project Agency Network. Okay, so this ARPANET now adopted the TCP IP protocol to be the standard for all the government agencies and all the contractors, all government researchers, to be the protocols that will be used to link and communicate over the internet. Is that okay? So the ARPANET is considered the predecessors to today's internet. So the previous what we now call internet was previously ARPANET, before the names was changed to internet. Okay, internetworking. Internet is from internetworking. Okay, so this is the big background of how the TCP IP protocol was given birth to, and the people behind it, the agency that was behind it. So this is the end of this first introductory part. So thank you very much for joining us in today's class. Thank you.